All right, we're going to go ahead and get started with our session here. This thing is microphone problems. Okay, thanks everyone for being here. We're excited to host this symposia today. I'm going to give a quick kind of 10-minute introduction into the session, introducing the autonomous platforms that we're going to be talking about for the full symposia here. And then I'm going to introduce Reiss, who's our invited speaker for the panel, and get our panel set up for discussion. And then we have a full panel discussion. So I'm going to go ahead and get started. We'll introduce our panel members in just a little bit. Okay. All right, so this session is focused on autonomous solutions responding to oceanographic and ecological monitoring needs of offshore wind development. There's a lot of different solutions, and we've been hearing a lot about those since Tuesday, since we've been here. I'm just going to cover some specific examples, and I'll go through ones that we've been involved in over the last few years. So we have a lot of approaches we can use to monitor the ocean. A lot of different platforms we can use, each with its own set of advantages and limitations. So not one platform is perfect for everything. That's why we are really reliant upon a network of observation systems. But today I'll be talking about some specific autonomous approaches that we've been using, comparing those to things like traditional platforms used for extractive surveys. So typically these are vessel-based, and we can run like bottom trawl surveys off vessels. We can do zooplankton tows off vessels. We can collect water samples for biogeochemical measurements using vessels. So these are very kind of the traditional platforms that we've been using for these types of measurements. When we say autonomous platforms, we define this, and for the purposes of today, as pretty much anything unmanned or uncrewed. These are things like wave gliders that can have surface and subsurface applications, sail drones, satellites, buoys and moorings, and of course gliders that we'll be talking a little bit more about today. So these have non-extractive approaches, so we're not removing anything from the ocean. But of course, vessel-based surveys can be non-extractive as well. Vessel-based surveys can have sensors like echo sounders that are non-extractive for measuring biomass. But for the purpose of today, we define an autonomous platform as something here, unmanned, uncrewed. These are just some examples. I'll give us a specific example about the gliders, because mostly what we're going to be talking about today are buoys, moorings, and gliders from the specific examples that we're going to provide for you today as the introduction into the panel discussion. So gliders, of those of you that may not know, the gliders are they're vertically profiling platforms, and they're buoyancy based. And so it means that they're very efficient in terms of battery usage, and they can be out in the ocean for sustained periods of time. They work because they're ballast, they use ballast to go up and down in the ocean. They work by having a pump that pumps water into the nose and pushes the battery forward to go down into the water column. It has an altimeter so it can detect the bottom, and then it can push the water out and come back up. So it's profiling vertically in the water column. It has wings on the side to give it forward motion. And so it can sample surface to bottom. It samples, sensors typically sample on average about every 2 seconds. And it can travel horizontally about 20 kilometers per day. And depending on the battery, it can be out for anywhere between 30 and 90 days in coastal systems. And we have the limitations, of course, of biofouling. That's typically our biggest limitation in our very productive coastal environments. So it can provide high-resolution data, and this is true for most autonomous platforms with sensors that are on it. They can provide for gliders, for instance, on the top right. That's a depiction of just an example glider profile showing high vertical and horizontal being time and space for a glider. For a mooring, that would be, you get very high temporal resolution in a specific area. But typically, these autonomous platforms provide that high-resolution data. They're typically cost-effective. Vessels, as we know, can be very expensive. We're having some issues with gasoline, if you haven't noticed. Fuel is very expensive, so vessels are becoming more and more expensive, especially now, but also maintenance of vessels. So a lot of research programs are finding, and even federal programs are finding vessels for their research a little bit more difficult these days. Some of the autonomous platforms can navigate wind farms fairly easily. Gliders have very adaptive sampling procedures where they can, they're relaying information at the surface, GPS coordinates that you can then modify every time it comes to the surface and change its path. Moorings, of course, can be placed in very near shore or near to the offshore wind platforms. These autonomous systems can also sample in hazardous conditions, so we're talking hurricanes and nor'easters that come through where ships have a very difficult time sampling. And there's been a lot of development over the past decade in the sensors that these autonomous platforms can carry, which has really been a lot of fun personally for me, but I think scientifically as well. We've been developing new biogeochemical sensors, new sensors for biology, so things like biomass, which I will talk a little bit about today. And so now using these autonomous platforms and in combination with traditional platforms, we're really interested in assessing ecosystem impacts. And I gave a few examples here, but I'll show you some specific examples in just a moment. So getting to the research priorities. So these were community developed research priorities. I think they were developed at the most recent State of the Ecosystem meeting, which was about two or 3 years ago. I can't remember now. 2021. It's right in front of me. Just a few years ago. And so here's some examples of the environmental research priorities listed. I'll touch specifically on linking the physical effects to biological effects, conducting feasibility studies to identify types and scale of potential effects, and then assessing changes in things like stratification and light conditions. So these are the things we're really starting to think about and really trying to address with these autonomous platforms. Now the next example I give is, you might have heard yesterday from Mark Baumgartner, but it's a really good example of how some of these autonomous-based approaches have started to become operational and now are being used to help support offshore wind development. So Robots for Whales program. Oh, it's not, the slide's not showing up as I had it, but it's okay. I was crediting Mark Baumgartner on here. Sorry, Mark, if you're listening virtually. I had your name and Hui and several sponsors and partners on there. So this is his Robots for Whales program that he's been running over the past few years, actually almost a decade. And so essentially it started with a handful of moorings with a passive acoustic sensor on it called the DMON that listens for whales, and so you can get whale detection data from it. And then it expanded into the glider. And since then, we are expanding it through our glider systems regionally, and now he has them in several gliders running down the East Coast in this example. And it's really nice because it's providing these data for whale detections along migration pathways for these organisms. So a very cool example of how these types of systems have gone operational. So now I'm just going to run through a few more examples. The first one is really focused on industry and that private sector of how they're starting to use and utilize these autonomous platforms for observations for offshore wind development. So on the left here, kind of moving on from Mark's work, there's a collaborative project that has a glider with that passive acoustic sensor that I was just telling you about that's been running transects off the coast of New Jersey in the Orsted Ocean Wind Lease area, detecting whatever whales are there. And what we're able to do with the gliders, because they have all these different sensors on them, including physical sensors, we can start looking at how oceanography is tied to these locations of the whale detections. And in this example here, we're seeing the glider track, which is in red, You can see some circles along that glider track that are pretty much matched with where we see these frontal systems. Josh talked a little bit about this on Tuesday at the ROSA session, if you were there. But we're starting to kind of see how we can tie oceanography drivers to marine mammal presence. So that's pretty cool to pair those drivers together. So that's on the left. In the middle and the right, we have an Ørsted wind fisheries monitoring project that we've been spinning up over the past year or so that combines traditional extractive techniques with these autonomous approaches that I've talked about. And so we have our traditional techniques like the benthic trawl survey, structured bottom survey, some of which is extractive and some are non-extractive, clam survey, and then eDNA. But for the autonomous approaches, we're using a glider that has fish telemetry systems, so we have receivers on the gliders for fish telemetry. We have the oceanographic variables that we're capturing, and we also have active acoustics or echo sounders that are starting to look for pelagic fish biomass. And the idea is to kind of see if we can use these gliders as a platform to augment or eventually help replace some of the surveys in those very specific offshore wind areas. So we're able to kind of ground truth some of that data with the traditional approaches. We have some state-focused efforts going on, funded through New York and New Jersey. These are also glider-based, but I think the NYSERDA has moorings, Josh, if I'm not mistaken. Okay, so we have autonomous programs going on for both states to support offshore wind development, but they share very similar goals in terms of what data they're providing. So they're providing data that's relevant to ongoing environmental and ecological change. And these are seasonal. We have seasonal glider deployments, so we're able to see these seasonal variability and a lot of different parameters, so physical, chemical, and biological. And the physical, in terms of the cold pool, we're getting sustained observations now in the cold pool, which is very relevant to our organisms that are migrating through the area. And biologically, we're now able to, with the sensor development, we're able to see multiple trophic levels from phytoplankton to zooplankton to fish to marine mammals using different sensor types. So it's very ecosystem heavy. Federally focused efforts, there's some examples from the Northeast. I've just put them in a bulleted list here, but Andy Lipsky's here and he'll be on our panel today he'll probably touch on a little bit more of these during his introduction. But some examples include complementing existing fisheries and ecosystem monitoring surveys with eDNA measurements, implementing uncrewed HabCam survey, so it's actually taking photos of the bottom to support the Atlantic scallop monitoring, expanding the passive acoustic monitoring efforts in the Northeast, so throughout the entire region, developing a multi-species bottom trawl survey simulator, and using advanced imaging approaches for marine mammals and prey. So Andy will probably touch a little bit more on those during his introduction. But one specific example that I want to introduce today, and I'm actually introducing our next speaker, Christian Reiss, when I'm doing this, because his group at the NOAA Southwest Fisheries Science Center in the Antarctic Ecosystem Research Division has been using gliders equipped with echo sounders to kind of ground truth the traditional vessel-based measurements of Antarctic krill for the CAMLAR program. They manage the krill fishery in the Antarctic system. And they've been trying to see how the gliders can perhaps replace or augment these vessel-based surveys, and within about a 2-year time period, they were able to show that gliders were a pretty good replacement for the ships, which is very timely because they're losing a lot of ship time in the Antarctic. So correct me if I'm wrong, Christian, and you'll be talking about it, but it's now fully glider-based program. So that's why we wanted to show this example. It's a very good example of how we can use these autonomous systems when we have limited ship availability. So with that, I'm going to introduce Christian Reiss. Come up. Let me get out of here. good.
Great.
All right.
Thank you so much, Grace and Josh and NYSERDA for paying for my way here a little ways and not any entry fees, which is great. I haven't been on the East Coast doing any kind of work in about 25 years, so it's great to be here to talk to old friends and make new ones. So I'm going to talk to you today about how we've... Yeah, I'll probably end up walking around anyway. Okay, thanks. So I'm going to talk to you today about how we've transitioned to an autonomous program in the Antarctic. Our group is small. The entire division is 14 people, and we work in the Antarctic from La Jolla, California. So we do a lot of annual shipments of things back and forth around, and it's considerably, it's a big deal to get it and move it along for all these years. Anyway, so the outline, I'll tell you briefly about us and what we do and how do we get to where we are. Then I'm going to talk to you about two of our programs. One is Freebird, which is the Antarctic program, and then Refocus, which is a new program that we just got funded, and we'll be getting our 6 gliders in another couple of weeks from Teledyne. And then some conclusions about sort of where we're at after essentially just about 3 years, 3.5 years of trying to get into the glider game. And Josh is responsible for us doing this, so blame him. All right, so basically who we are. The United States is a signatory to a number of treaties and conventions in the Antarctic. The big one for us is the Convention of the Conservation of Antarctic Marine Living Resources. That mandates that the nations that join that do some work. The Antarctic Marine Living Resources Act gives us the requirement to do that work for NOAA and for the Department of State, who is our principal stakeholder. Although science endeavors in the Antarctic are also a stakeholder as well as other groups. So the work that we do is mission focused towards providing advice, and people that do other work in the Antarctic do the work that's more basic science oriented. So ours is always trying to focus on what is needed for management, and it's changing now because the fisheries are also changing. Climate's also a big deal. So we work at the Antarctic Peninsula. It's a series of islands with a very deep shelf, basins that are 1,000 meters deep. It's a pretty dynamic environment. We've had temperatures as high as 75 degrees Fahrenheit in recent years. So the environment there is changing really, really dramatically. And so understanding what's going on there and being able to manage what's going on is quite a big deal. For about 30 years, starting in 1988, we conducted surveys sort of in the traditional manner, although with a great big ecosystem focus on birds and mammals. One of our camps that's in red there is been occupied since 1977, and these are primitive camps, right? We put people on there, they live there for 6 months or 5 months, and then we pull them out. So the ship that we have, or the ships that we've had, have been chartered to do two things. One, to do our surveys, which are sort of those dots on the map in the middle, about 125,000 square kilometers, and then also to provide support to those camps. On the land-based side, we study penguins and seals as well as other animals. We look at the reproductive success, their feeding ecology, et cetera, et cetera. And then the big guy in the arguments are krill. For those of you that have had krill pills, that's where we get them from. And we've chartered vessels for about 30 years to do this. That is, in our funding line, this is how we do the work. We're not given a ship to do it. We have to pay for it. So you can see in here 2 areas, one in light blue, offshore, one an area in red, as well as the krill density estimates that we've gotten from acoustic trawl surveys that we've been doing since the early 90s. And basically, what we want to do is figure out whether or not, using gliders, we can replicate some of these time series and then do that work using gliders in the future. The problem we came up with was that, much like a mob boss, chartering vessels doesn't care about anything other than getting paid. So every year, pay me, pay me, pay me, no matter what else is going on. And a vessel like this is about $60,000 to $70,000 a day. We used to have to transit for 2 weeks between Chile and the peninsula in order to do our work. So you can already imagine we're talking about hundreds and hundreds of thousands of dollars just to get to the work zones. So saving money is a big deal, and essentially the costs of the ship eviscerated our program over time. It wasn't the loss of money, it was just that it just got too expensive to do what we were doing. So how can we change our program to provide advice to NOAA and the State Department? We had to rethink our program, and we were tasked with developing this over about 18 months. One of the most important needs was to maintain a time series or an index of a time series of krill, because that goes directly to the management. It was to estimate the amount of krill moving into and out of fished areas, because the fishery is concentrated now into very, very tiny areas, 35 kilometer by 35 kilometer areas, and they extract thousands and thousands of tons of krill. So the question of what's going on in the fishing areas is now much more important than what the average concentration of krill in the system is. Because we were losing the ability to collect net tow data, we need to come up with other methods to collect ecological data from whatever tools we decided on. The constraints, again, are that we needed to be able to provide data for management. That's number one. We had to be flexible, cheaper than a ship charter, hopefully. Had to be sustainable in a flat budget environment. And it had to be manageable with a small group of people, 4 to 6 people. I was not able to get more people because we don't have money. So we had to retrain the people we had from being biologists or chemists or whoever to be able to do this kind of work. And so we asked the question, how much can be automated? Could we get acoustically equipped gliders or survey vessels that are cheap enough that we could buy a few of them and run them in the Antarctic? Could we find simpler echo sounder, ADCP, acoustic Doppler current profiler instruments that were easier to operate than sort of having 2 different systems and having to manage all of that? Could we get new and different instruments on our seals and penguins to give us more information, cheaper? We introduced a huge amount of camera systems remotely so that the people that were going to the camp and were no longer being supported by having a ship if they were in trouble, right? Could we do stuff using cameras? And so this was our idea. Could we do this? But we had to ask an important first question, right? And that is, can a glider, if you fly it around, can you get our time series back that we were looking at? Because if we can't, then even theoretically this doesn't work. And so if you look on the left of this panel, what you see is what is a traditional survey. Basically, you have a ship, it's got a series of echo sounders on it. It drives around, it stops every once in a while. We take a net tow, count everything in there, get the length frequency of krill, which we then, I'll show you in a second, do a little bit of hocus pocus, and magically we get the biomass of krill or whatever pelagic fish, et cetera, that we're looking for. For an autonomous program that doesn't have a ship to collect the length frequencies of the species, you have to find some other species that can give it to us. And in the Antarctic, in this region, we do pretty well with penguin diets. That is, they track the length frequency distribution of krill in the system. And so we thought that if we paired a glider with an acoustic system with the abundance or the length frequencies from the penguins, that we could combine those two and generate some type of time series that would be useful. This is sort of your traditional acoustic transect. It's a ribbon through the water. The acoustic signals, you can see it, these different frequencies show up differently based on what's in the water column. And we use these multiple different frequencies to tease out krill from other scatterers that might be there, for example, pteropods or copepods or whatever else might be in the way, okay? A glider does something different because it moves through the water in this sort of sawtooth pattern. it's always sampling, those orange bars, always samples the same amount of distance below the glider. So there's an interesting advantage to a glider, and that is as far down and as far deep as you go, no matter what frequencies you're using, you're getting information that you probably weren't getting with a ship in some ways. So we conducted a simulation study where we sampled through all of about 10 years of our acoustic data, and we simply compared the biomass densities that we were getting on an annual basis that we got from the ship versus what we would get from the acoustics, and you see that in the lower right-hand panel. And basically what you see is that acoustics from a glider, if it was flying through our area, can do a very good job of recovering the temporal pattern, the relative abundance of krill in our system. And that's a big deal because it allows us to move forward with what we were thinking. So we can recover the time series. The issues then become, if a glider is only moving 20 kilometers a day, what's your time-space scales that stakeholders, managers, fishery people are okay with discerning as synoptic, right? We try to do a big acoustic trawl survey as fast as we can. We're moving slower, so we have to have discussions with stakeholders about how much uncertainty they're willing to use and have in the assessments that we do. If you want to be able to fish krill down to the 1/10 of a gram, then we can't use this. If you're willing to have an assessment that says plus or minus 100 tons or 1,000 tons or whatever the number is, okay, then we can use this. And so we have to have those discussions openly with the stakeholders about how things go. So, what uncertainty are you comfortable with? So looking at these things, we decided on Freebird. This is the Antarctic program that we have. And basically, it was a multi-scale program that we put together, where the yellow dots are a series of acoustic echo sounder moorings that we put in. They take about 20 minutes to deploy. They take about 20 minutes to recover. Really cheap, really fast, put them in the water, get them out when we need to. Plus the gliders in 2 different areas. One, in one of those areas that I showed you, that is trying to replicate one of our time series areas, and in the other off of one of our predator colonies, where we can look at the interaction between predators and prey at the same time. And hopefully it's lower cost over time. We'll see. So these are the instruments that we came up with. Doug there in the upper panel, he's 6'6", and so that's a big glider, and yeah, it's a big glider. And you can see the acoustic setup that we have, which is a 3-frequency single band that hangs underneath the science bay in the middle of it. You can see on the bottom the small acoustic mooring that we have that we can deploy fairly quickly. And so we calibrate all these instruments in the test tank at the Southwest Fisheries Science Center. If you ever get a chance to come out west and see it in La Jolla, it's a pretty impressive place for testing all sorts of acoustic equipment and other instruments. So we received our gliders in January of 2018. And we had to have everything ready for shipping by July of 2018. So we did 4 deployments over the course of 3 months. The first deployment, we almost ran the glider up onto the beach in front of all the surfers, so it was a shocking time for us. But we did 4 deployments, a little bit more complicated each time to get comfortable with it. We then packed up everything, shipped it south, and we did an 88-day deployment beginning December of 2018 and picked up in March of 2019. We had 2 pilots that operated the gliders for that period of time with some help from the people from Rutgers, because without them, nobody does gliders anywhere. And what you can see here is on the upper panel on your right is our approach, right? What we wanted, the planned allocation of sampling. The red lines and the black line are just the glider versus the ship-based program. So you can see what we're trying to replicate in terms of space. And then on the bottom, you can see how we actually did in terms of covering space during the deployment. And there's only one area where we couldn't get to, and that's because in the Antarctic, occasionally you end up with a 30-kilometer iceberg that sits on top of all your sampling, and you try not to go near those with anything. So there's a little bit of a hole. But in general, we did this about 90 days. This is what the pattern of acoustic density on your left looks like for the two different surveys north of our predator colony. You can see how tightly that survey area is. That's about 1,300 square kilometers. And the integrated biomass in the Bransfield Strait in the other area. We happen to have some ships out there doing an entire Scotia Sea South Atlantic survey. It was a big CAMLR thing. And so we were able to take some of the acoustic transects that were running over where we were operating to do our comparisons. And basically at the end, don't worry about the numbers there, we were within about 10 to 15% of what the biomass is that the ship came up with. And there was no pattern that we were always over or underestimating biomass. So again, we feel pretty comfortable about this. Until COVID, we were adding a glider a year to our program. And what you can see here is we replicated what we were doing, but in the Bransfield Strait, the red and the blue there, you can see all of a sudden what would happen if you added an additional glider. The amount of coverage that you're getting is tremendously more, and your synopticity goes down because now you can put the two gliders in slightly different places and end up with a shorter time frame over your integrations. The cost for deploying the extra glider is virtually nothing. It's a few hours on a boat. So it's very cost effective to do this in the multiples rather than to do a single glider, except for the cost of the gliders. Okay. COVID also gave us an opportunity, though, because we had this money that we weren't going to spend now because we couldn't do some things, to go back and get more ecologically important instruments developed. And these are all commercially available now. One was an optical targeting camera that you see in the upper panel. You can see I don't want to say what kind of animal that is. It's just not a penguin or a krill. So and basically, it allows us to validate that what our acoustics are seeing, and that's important, right? So we needed to do that. We accomplished that task. We feel good about that. The second was to replace the narrowband 3-frequency monster acoustic sensor that you see on the middle panel with something that was much more compact. And this instrument actually processes all the data, sends the data back over Iridium, and we get the acoustic data back. So if we lose the glider, we can still do our assessments. And the third is a shadowgraph plankton camera. And there's a number of these systems out there in different places, different people use them. But we wanted to develop one for the Slocum glider, and it's now for sale by the company. So we started with that. So that's the Freebird program, and it's ongoing, and it's what we do every year. Refocus is slightly different. 3 minutes, I'll get through. Okay, so Refocus was just recently funded by OMAO to the tune of $2 million for 6 gliders, all with shadowgraph cameras, and it's going to operate in California. And basically, what it is trying to do is to replicate or augment Cal Coffee. Cal Coffee is the longest running plankton surveys in the US. Goes back to 1947. It's now quarterly. It's under a lot of pressure for time for the ships. It's certainly not going to be able to do more work with respect to things like heat waves or other event-driven things, and we need something else that we can use. And our goal is to try and replicate it using 2 different fleets, one from Scripps and our new shadowgraph gliders. And what we hope to do is to be able to identify the critters of importance that can tell us about changes in the ecosystem, and then to be able to use those distributional patterns to make management decisions. This is the first deployment. One of the things we get is thousands and thousands of images. We expect that for every set of deployments, we'll be working with about 8 terabytes of data, not something you can put on your laptop and play with. So we've moved all of our processing to the cloud, and we've leveraged a lot of NOAA programs to do this. all of those images that you see on the right, they're exactly the same size. They're exactly the same size as they are relative to each other, and that's one of the good things about the shadowgraph is it gives you lengths. So it's a really cool pattern. There's some copepods and things in there. So conclusions. In a time where we don't have resources or we're limited in the resources that we have to find ways forward. And autonomous vehicles of all kinds are going to be that way forward. We just have to think about the tools that we want and spend some money to develop them. Things are moving really, really quickly. These are the first ecological tools for the slocums. The other biogeochemical tools are nicely developed. The PAMs and things like that are working. But now we can add real sampling of the ecology of the systems to these tools. The rest of it is just we have to do the work, right? And we have to know what we want to sample, and then we have to go out and do it. So I'll stop there.
As we transition to the panel, please, we invite questions for Christian in his talk. So I think we'll do that with the note cards for those that are here, and use the app. So if you have questions for Christian, I will ask our panelists to slowly migrate up to the table as we're doing that. So any questions with the note cards?
Or microphone.
Are you allowed to do that?
Am I breaking rules? Questions?
All right. Thank you.
Anyone? Question?
All right, we have a question for you, Christian.
All right, the first illegal question of the conference. So it looks like Elephant Island got dropped from the glider survey area. Was that an ecological decision, budget decision, or?
Well, it was both. So Elephant Island is an area that's out in a very dynamic, energetic, and part of the system. And until we have an ability to know where those gliders would go if they get off course, that was one decision. The second decision is that most of the fishery used to operate off of Elephant Island, which is why we sampled it. Most of the fishery, about 85% of it, is now within Bransfield Strait. And so it was both an ecological management and time decision.
I have another question from the room. Are you concerned about glider collisions, damage due to offshore wind, and stakeholder marine activity? Do you share their location in real time?
So, last part first. All of the data goes up to one of our management things and is available. So it's almost right away. The acoustic data will be available as well. The shadowgraph data, we expect, say, let's in 5 years that we would be doing real-time analysis of the plankton images and then sending the information back up. My view on gliders is always against a $60,000 a day ship. Okay? I can get a glider every 10 days or 7 days. So my answer is if you lose one, buy me another. Whoever it is, buy me another. Because I'm saving you $200,000 a month. And that's the view that we should have to these. And then, just make sure that the number on the glider doesn't refer to your own account at your business, so the bean counters stay away. But really, we have to think about these things as not disposable, but you're putting them in the ocean, you're going to lose them. They're small. Get another one. And that should be, in the long term, that needs to be a view that we have, so we're not afraid to put them out. It's not that we want to lose them, but we don't want to be afraid to do the work.
Any other questions in the room for Christian?
Nice job, Christian.
Well, we're about to have one.
Yeah, so thank you, Christian. Thanks, Grace, for setting us up here. So what we wanted to do with this panel, I don't know, for the tech crew, I'm going to move around. I don't like standing behind podiums. Awesome, I got a thumbs up. So what we want to do with this panel is shift this discussion. Christian gave a great example of how these are being used for a management process in a different part of the world, whether it's the Antarctic or the West Coast. In the case of monitoring for the plankton survey, what we'd like to do is shift this conversation to offshore wind specifically in the context of this meeting. And we hope this is a conversation with our virtual and our in-person audience and our panel. We're very excited to have our panel here. In lieu of having formal introductions, we're going to let our panel introduce themselves. What I will say is that we're really excited to have them here because they bring a diversity of perspectives to this question about the use of autonomous systems, again, specific to offshore wind. And so I'm going to kick it off with a question to everyone except Christian, because Christian just had 20 minutes to introduce himself. And that question is, how are your organizations presently utilizing or planning to utilize autonomous systems in the specific context of offshore wind? And we're going to kick it off with the private sector perspective.
Thank you, Josh. Good afternoon, everyone. My name is Greg DeCelles. I work with Ørsted Offshore North America. I'm our fishery science specialist, so I work on fishery science issues across our project portfolio in the United States. We've got a number of instances where we're using autonomous systems for monitoring. I think those span a kind of a continuum from semi-autonomous systems to fully autonomous systems. First, with regards to fishery science, we've developed across our different projects in the U.S. a really large network of acoustic telemetry receivers. We're deploying over 100 acoustic telemetry receivers for multi-year deployments. So I think that's really going to add to some of the exciting regional research that we've heard about this week. We're also doing some short-term monitoring specific to individual projects. So for example, for South Fork Wind, we're using passive acoustic monitoring mounted with the hydrophone mounted to a Slocum glider with the intention to monitor for cod during the spawning season as we conduct some of our construction activities. Some of the other things that you've heard about this week include the use of both pelagic and benthic baited remote underwater video to assess both the abundance and species composition, but also the distribution of fish around the ocean wind lease area. We've also started using gliders and incorporating that with acoustics, multi-channel acoustics to look at the fish community, but also the zooplankton community as well. And for scallops, using the HabCam survey system, which is autonomous yet towed behind a vessel, so that's kind of that semi-autonomous. But that allows us to get transects of scallop distribution, abundance, and size structure, as well as benthic habitat information across our Sunrise Wind Lease area. We've got quite a bit going on with benthic monitoring as well, including using remotely operated vehicles equipped with state-of-the-art digital cameras to look at benthic habitats, scour protection layers, what's growing on the foundation. And then on the marine mammal front, we've got a lot of initiatives there as well, using these advanced autonomous techniques. We've heard quite a bit this week about the EcoPAM project done in collaboration with folks at Rutgers, using gliders mounted with passive acoustic hydrophones to listen for the distribution of whales, and doing that while also collecting a suite of oceanographic data to understand how the distribution of those animals overlaps with oceanographic conditions. We're also going to have long-term passive acoustic monitoring across our lease sites to look at interactions with marine mammals. And we've also got a project with Stony Brook University at Sunrise Wind using active acoustics and particularly a bottom lander to examine the prey fields for North Atlantic right whales and how those are potentially affected by the development of offshore wind.
Great. Thank you, Greg. I'll switch over to our state perspectives, and we'll start with New York.
Thanks. I'm Kate McClellan Press. I'm a senior project manager in environmental research at NYSERDA. And NYSERDA has been focused on kind of better understanding the marine environment offshore New York in the master planning phase for offshore wind, which kind of looked at an area of concern off of Long Island out to offshore. And then we've continued to look at surveys focusing on kind of pre-development information. So trying to provide information early in the process, both so we better understand the environment and also being able to provide that information to developers so that they have it earlier in the process to kind of de-risk things. This has included 2 mid-ocean buoys that we had out for multiple years, both collecting information on wind speed, but we coupled that with wildlife sensors, so looking at birds, bats, and then underwater, coupling that with passive acoustic monitors and VEMCO receivers to look at fish. So kind of trialing those buoys as platforms of opportunity to see what else could work out there. So that was actually, I think, the furthest offshore deployment of a nanotag receiver thus far. In addition to those surveys, as announced yesterday, we're going to be funding Stony Brook University and Rutgers University to deploy gliders for 2 years in and around the new lease areas. The focus of that is both on passive acoustic monitoring to kind of better understand whale presence in that area, but also looking at oceanographic variables to better understand the dynamics of the cold pool. And we're coupling that in the same area with a survey that's going to be conducted by the Wildlife Conservation Society, looking at deploying bottom-mounted passive acoustic monitors in the same area. Their focus obviously on marine mammal detections, but coupling that with bottom temperature loggers. So trying to provide information both on biological presence and a better understanding the oceanographic characteristics of that area.
Thank you, Kate. And we'll switch over to the state of New Jersey and start with Kira.
Thank you, Josh. So I'm Kira Lawrence. I work for the New Jersey Board of Public Utilities Clean Energy Division, and specifically I'm on the offshore wind team. My agency is the one that basically runs the solicitations for offshore wind in New Jersey and then manages those projects. So my expertise are in climate and environmental sciences and ocean sciences. We at the BPU, along with our partners at DEP, co-administer the Research and Monitoring Initiative, which is an effort to assess the impact of offshore wind on natural resources off of our coastline. And we mimicked New York's effort to charge a research and monitoring fee in our most recent solicitation in order to have the resources to do that. So we recently funded a Slocum glider-based project through Rutgers, in which we're going to deploy 3 Slocum gliders in the waters off of our coastline. You can see the track of those gliders. Intended track is the red line from Sandy Hook down to Cape May, this zigzagging path seeking to capture not only the nearshore environment, but also into the lease areas and have some overlap with transects that Rutgers has previously implemented. We are employing a paired glider approach with a full complement of both physical, chemical, and biological sensors in an effort to try and do our best to capture what's happening with the natural resources off our coastline. The paired approach is an effort to try and maintain glider endurance, so they can be out there for longer if you don't overload a glider with lots of sensors, and to try and not have interference between the passive and active sensors on those gliders. The third glider we basically funded was an effort to try and capture the dynamics of the cold pool in between these seasonal deployments of the paired system, so that we would get as much information as possible about the cold pool from its inception in the spring through its breakdown in the fall. And I think largely we are hoping to provide a sort of full battery of baseline data that will have utility not only with intersecting the different data sets that these gliders collect, but also have utility to other projects funded by the RMI or all manner of other entities that would be, again, trying to understand our natural resources and how they intersect with offshore wind. And so I'm going to pass the baton to Renee. to talk a bit about some other efforts in New Jersey.
Yeah, as everyone's talking, I'm like, okay, well, don't mention that. I got to start with a joke or I get nervous. But I'm Renee Riley. I'm a research scientist in the Division of Science and Research at DEP, the Department of Environmental Protection for New Jersey. Along with Kira and Colleen Brust out in the audience there, we are really the feet on the ground for the Research and Monitoring Initiative in New Jersey. And so since you heard quite a bit about our gliders, I just wanted to mention kind of the way that Greg did, just the other areas that we're using autonomous platforms. So right now, as we're kind of gearing up, and I'm sure you can sympathize, Chris, with getting the actual equipment is a whole separate process. And so in the meantime, we're leveraging the existing gliders that the state of New Jersey has. The Bureau of Marine Water Monitoring has a glider that Rutgers runs for us to specifically look at like water quality measures, but is able to actually alter its track to kind of start to collect some of these initial data streams for offshore kind of spaces. So the tracks in black, I believe, are the existing glider deployments that DEP and Rutgers have. And so they're kind of essentially going out further to try to capture some of those time series early. Some of the other things, of course, we're looking to expand the passive acoustic monitoring off of New Jersey as part of the greater effort here in the Northeast to do that through archival bottom-mounted PAM. But also the gliders will have near real-time passive acoustics on them. And there's a whole bunch of, a suite of projects that are not yet fully executed through the RMI. We're just were formed in December of this past year. So we're just getting started, but we hope to make use of a bunch of other platforms, including moored near real-time passive acoustics for cetaceans, as well as using the benthic mapping tools that we have. There's folks at Rutgers that, of course, are involved in that as well. Expanding the MODIS network in whatever ways we can for birds and bats, expanding acoustic telemetry receivers for fish, VEMCO stuff, and also, I don't know if this counts, but satellite tagging efforts as well for whales and harbor seals and all of those things. We're looking to really kind of get to steal your phrase, get an oar in the water on each of the taxa-based groups.
Thank you, Renee. And then we'll switch to our federal perspective. Andy.
Thank you, Andy Lipsky. I serve as the offshore wind science team lead at the Northeast Fisheries Science Center. Really glad we have Christian working for our agency. So I'm not going to repeat anything that, obviously NOAA and NIMS is working in this realm of looking at autonomous or semi-autonomous surveys for the purpose of meeting our mandates to manage populations of fish, marine mammals, sea turtles, and other protected species. Relative to the question, which is offshore wind, and I think I gave a presentation yesterday, we have a challenge before us because many of our surveys are conducted using traditional platforms and approaches. Some of them are using semi-autonomous approaches, such as our HabCam surveys in order to support the Atlantic scallop assessments, one of the U.S.'s most valuable fisheries. And so we're looking at, this is a challenge, and autonomous and semi-autonomous solutions are obviously a way for us to move forward. And so we are, I mentioned this yesterday, we have some projects, we have some oars in the water with, sort of at the R&D level or even maybe further along. Grace presented a slide that highlighted a few of those efforts. I am the dumb person here. These efforts are led by much smarter people, but I'm talking about them. So Sophie Van Parij's efforts on passive acoustics, she's a major lead in our protected species branch. You've got it behind me. I didn't even know you had that slide. Yeah, so you have the slide. Many of our experts are listed here in terms of our contacts. I'm not going to go into each one of these, but we have our oar in the water, looking at 3D echo sounders. Mike Check and myself have been doing some surveying out at Block Island with the CPIX instruments. It's again R&D, testing it out, looking at mapping fish biomass. We have a really interesting effort of using an uncrewed vehicle mounted with a HAB cam in order to support Atlantic scallop surveys and wind energy areas. Marina Martini is our contact there, and those are in the early stages. One of the things that, and Christian got into this, one of the things that we're also working on is, how do we take these new sampling technologies, and from a NOAA perspective, we don't tend to have, we do work on research and we get studies and they're done in a certain period of time, but we're looking to operationalize surveys. We're looking to do something in order to meet a management deadline and do that consistently over time. So we have a project right now looking at the bottom trawl survey, the spring and autumn bottom trawl survey, simulating changes in that survey due to offshore wind energy development. So if we change the survey and use, whether it's using a different platform or autonomous platforms, how does that affect our management advice? What are the considerations? What type of uncertainty, as Christian said, uncertainty we're going to have to live with? And are there ways to address that? So there's a whole range of projects we have at NOAA Fisheries and the Northeast Fisheries Science Center to address the offshore wind aspect. This is definitely a solution to that. There's a lot of work that needs to be done, but at this point in time, we're at various early stages from semi-autonomous to autonomous. Thank you.
Thank you. So you've met our panel. We want your questions. We want this to be a conversation. So I have one quick question while you all think of that burning question that you're going to ask of our panel. How cool is it that we have this group of experts here to ask this question? So I'm going to kick it off. We invite our virtual audience to use the app, which we think is working, and we'll use our note card system. And at the risk of breaking any rules, we'll also say if you want to raise your hand, you can do that, and we'll hand you a mic. All right? So, question, I'm going to go to Greg. From your perspective, what are the opportunities for the expanded use and the current limitations of autonomous systems in offshore wind monitoring and research? So, expanded out use opportunities or some of the challenges.
Thanks, Josh. If I start going on for too long here, just give me the hook, okay? So in terms of opportunities, I think it's really a lot that's ahead of us, and it's very exciting to think about. I can imagine if we come back to this conference in 5 years' time, the new technologies that are going to be generated through these offshore wind monitoring opportunities. It's really exciting to think about what's ahead of us. Some of the advantages that I see with using these types of technologies that have been discussed today. First, I think we're shifting from the traditional way of doing fishery science, which is getting snapshots of abundance or distribution in time, and moving towards a more continuous stream of data collection. I think that has a huge number of advantages, and it's really going to expand our understanding of the marine ecosystem. I think, more practically, some of the things that I think are advantages are reducing permit challenges associated with some of these surveys, reducing risk to protected species, reducing the mortality that's associated with a lot of our traditional sampling techniques. From a developer's perspective, we have a big emphasis on health and safety, especially those folks going out to sea. We've already talked about how these autonomous platforms can kind of work in any weather conditions, so we don't have the same weather windows that we have with, putting people on boats out at sea. And it also, reduces the risk generally to people if we can do this autonomously versus sending folks offshore. There's no untrawlable habitat when it comes to a lot of these autonomous systems. So I think we're able to sample a wider range of the marine ecosystem in the benthic environment, which is really important. We're also going to be able to collect just an incredible amount of oceanographic data. I think that's important for understanding the impacts of offshore wind in general. But I think the utility goes far beyond that, right? We can start to think of using this data as, predictive variables and models, thinking about things like habitat models, thermal niche models, predictive habitat occupancy modeling, and even informing things like coastal oceanographic forecasting models and weather forecasts. So the utility of this data goes far beyond just understanding what's happening with offshore wind. And I also think, in terms of the R&D, like I said at the outset, I just think we're going to have so much room for innovation and expansion. And we've got a great group of people here in this room and our colleagues elsewhere who aren't able to make it. A lot of brilliant people working on these things, and I just think the future in that aspect is really bright. In terms of the challenges, I do think we need to talk about those. I think, a lot of the challenge I see is that these tools, while they're innovative and really informative, they're not compatible with the way that we're traditionally doing fishery science, particularly fisheries independent monitoring that's done by the states or federal agencies. So this represents a pretty big phase shift in how we're collecting data, and trying to marry those two data streams together, I think is going to, represent a long-term challenge. One thing I talked about on Tuesday, which seems like a lifetime ago, is, fishermen are important stakeholders in these conversations, and a lot of these techniques that we're all familiar with and excited about are less familiar to our fishing industry stakeholders. So getting them acclimated with these techniques and understanding of these techniques and trusting in these techniques, I think, is going to be important for bringing the transparency to monitoring that everyone really wants to see. Another potential downfall is, our inability to collect routine biological samples, things like maturity and fish condition that we've all become accustomed to working with. Data management, I think, is both an opportunity and a challenge. I think we're talking about terabytes of data here rather than spreadsheets and access tables. And then species selectivity. A lot of our fisheries independent sampling techniques were derived because they can sample a wide range of species and size classes, and that's hard to replicate with a lot of these other techniques. So there's trade-offs to be involved there. I think there's a couple of unknowns too that are worth mentioning. One is, from a developer perspective, we need to make sure that monitoring isn't interfering with our construction and operation activities. So I think that kind of runs a gamut for these different technologies, and thinking about how compatible it is with our activities in the lease sites. And then, also thinking about the potential for interaction with other ocean users, right? I think in some cases we're reducing user conflicts by moving to this more autonomous system. In some cases we may have a risk of increased user interaction. So just things that we need to be really mindful of kind of as we expand this going forward. Thanks.
Thank you, Greg. Kate, any thoughts on this from the state perspective?
I mean, Greg covered that so well. There's
Yeah, I know.
really almost nothing to add, but I want to build on a couple of maybe really small points that he made. As far as the opportunities, just mentioning that we're seeing a lot of new technology providers coming into the field with an interest in doing monitoring work for renewables, and that's really exciting, and we want to be able to support small businesses that are coming into the field. But also at the same time, it's one of the barriers is connecting them with this community that is asking the questions, doing the analysis, and kind of making, building those partnerships is something that I think we have to focus on. One of the things I think we might run into is the demand for these types of surveys, and being able to meet that demand, both with the physical equipment, the deployment capabilities, and then on the other end, the people who can do the analysis and answer the questions that we're asking.
Thanks, Kate. I don't know if there's any burning thoughts. We have questions from the audience, so I might shift to that if that's okay with the rest of the panel.
We'll start with an online question, and that is, since I think Greg mentioned it, and I think Kate, you just mentioned it too, are there efforts to integrate the data from disparate autonomous monitoring technologies across agencies and organizations? How and what is the best way to accomplish this?
I'll suggest Andy. Am I putting you on the spot, Andy?
Yeah, you are.
All right.
Yeah, we need to do that. There's some examples where that is happening. We've recently, I think Sophie's paper on setting some guidelines for data collections, super helpful. But that was one of the things I was going to mention as a chat. Greg said everything perfectly. I wouldn't have added anything. The one thing that wasn't in there was just this group hearing the projects here. It's dizzying, and coordinating the question of disparate efforts, and how across the full range and suite, because we're talking about ecosystem monitoring, we're talking about biological monitoring, we're talking about very specific species of interest. It runs the gamut, and there are mechanisms out there potentially, but we're not fully using all of those, and many of them, as Greg mentioned, they're very, very data heavy, and those IT solutions haven't totally yet been solved in terms of where's all this information going to sit, and also relative to private data collections and public data collections, what is the availability and shareability and timeliness of that data. So I'll just go back to my response. We have to do this. I don't think we're meeting this need right now, which is maybe an unsatisfying answer.
Yeah.
Renee?
Yeah, I wrote that down too, just, data management and QA/QC and warehousing. So there are places where a lot of these data streams live, but there are data streams that don't have a house. So two important aspects are going to be building the infrastructure for the places that there are not warehouses, or maybe plugging into existing ones. If it's already built, don't reinvent the wheel. But also standardizing what's going into those and making sure that everyone has kind of a agreed community standard that this is where we're going to put those things and on what timelines, right? And, you run into all kinds of issues with that, obviously, embargoes and things like that. So it's important that we have the conversations here, and I would just add, if we can lean back on those regional entities, not to make ROSA and RWSC, the answer to everything on the last couple of days, but it really is those subcommittees where these kinds of conversations are happening and need to continue.
And Christian, not to put you on the spot, but you gave an example in the CAMLAR environment. Are you finding ways in which different countries are coordinating on some of the integration of these things, or is that slow to happen?
It's hard. Some nations consider fishery data theirs. NOAA, it's yours, so you want it, you get it. The issue becomes whether it's QA'd, QC'd. I think for the overall monitoring in the Antarctic, there is a very large push to make sure almost all the data that get collected are available in a timely manner, to a point that it is almost the only thing that people talk about. And it's not okay to do that because there's real issues with data. But, for example, the optical data for plankton, that's all open in most around the world now. And there's huge programs to make sure that people are seeing what they think they see, and they've got ways of QA and QCing it. The time for keeping the data to yourself, it's gone. And so wherever it is, at least at the federal level and sort of science levels, it's not going to be okay to keep the data. So, and that's good.
Great, thank you.
I was just going to underscore what Renee had said. I really see very, very important role for these entities that are trying to work on regional coordination. I think we're sort of at the precipice of, or already into this major expansion of, study and development of offshore wind, and it's only going to get more complicated. So I think, it's at this meeting, but more broadly, really been highlighted for me the importance of the RWSC and the ROSA efforts, and as state entities and federal entities and developers and whatnot, like as a community, we really need to think about how we have those organizations get the support that they need to do this hard job, right? Even as a research scientist trying to coordinate a small project, the logistics is a big part of your bandwidth, right? And so trying to imagine that those single projects are going to be able to coordinate across all that's happening, I think is really unrealistic, and the foresight of the community to think about these regional entities, I think, was great, and they really need our support in order to play this critical role as we move forward.
Another question, Grace?
Oh, Josh.
I was just going to add one more thing. Yeah. I wanted to highlight one really good example of a way that we've been coordinating on the passive acoustic monitoring, and Andy kind of just briefly mentioned it, but NOAA and BOEM, in addition to putting together guidelines on kind of passive acoustic monitoring, deployment, and data collection, also organized a working group for federal agencies and the states who wanted to fund passive acoustic efforts, and that was incredibly helpful in kind of informing the states as potential funders on kind of how to do that standardization work and have those conversations, but also in coordinating across states. So Renee and I have been able to communicate about those efforts and make sure that we're coordinating on locations and just the standards that we're looking for. So those small group conversations have been incredibly helpful.
So I get to ask the hard one next. Does autonomous technology mean the death of field biology and natural history? I had to ask it. It's a good question.
Which taxonomist said that?
Yeah.
No one wants it?
I'll take that.
Go ahead, Chris.
Everyone's rushing to the mics for that one.
There's a $1 billion lotto, and if you win it, fund taxonomists. Natural history is critically important. We don't know an animal just because we know its genetics. Understanding the animal is half of everything we do. So the loss of taxonomy, the loss of natural history, it's a problem for all fields. In the Antarctic it is. Where we can support it, we should. How you do it, I don't know, because it's a big problem, and it's a big problem across the world. So, in my mind, if we don't solve it, things like looking at that shadowgraph imagery, where we're trying to understand either a species or a functional group and what their role is when they're together, or looking at critters that we don't see often in nets because they're crushed, and now we have a perfect image of it. We need to be able to identify those to some level that allow us to make inferences about what's going on. So I would just argue that, although maybe it's premature to say that they're gone, hopefully not, but they're an endangered species, so they should be protected.
Anyone else?
I have just a quick answer. One of the things that the Science Center, Northeast Fisheries Science Center, has been doing for quite some time now is collaborative research, working very closely with the commercial fishing industry, through our research study fleet efforts. Our study fleets are responsible for bringing a lot of biological samples at times of the year where we're not out collecting them. And so those are definitely opportunities. We do need to use our human bodies and interact with nature physically, and collaborating with industries, and maybe the wind industry is sort of that industry of the future as well. You'll be visiting your turbines at some point in time for maintenance and operation. So taking advantage of sort of the existing stewards, like commercial fishing operations or recreational fishing operations as well, does provide opportunities to, as Greg said, to continue to build trust and interaction.
Great. All right, thank you, by the way, for these awesome questions. We have almost too many questions now to get across. And what I might ask our panelists, we have the questions recorded, and I know through the app that stays open for like another 7 days, I think. So there might be a chance for you to respond to some of these questions, and we'll save some of these that we can't get to, because we may not. I think this session ends at 3, right? Yes. I don't want to infringe on people's coffee. All right, so here's a question about regional coordination. We touched about a little bit with the data side and the importance of some of those entities, RWSC and ROSA. But the question says, with all the individual projects that you've all mentioned, scattered across the outer continental shelf, regional monitoring is going to be a key. How close are we to implementing a cooperative regional monitoring program that covers the entire area occupied by all these individual projects? They're so eager to answer, aren't they?
I'm going to agree with Andy's visual. It's like not very far along, but we need to get there. And I think that we're already seeing the beginning of a bandwidth problem, right? There are a finite number of experts who do these things in these regions, and if they're having to pay attention to 6 different potential projects, all asking them to do the same thing in a different spot, that's not a very efficient or effective approach. And so I'm just going to harp on the importance of coordination in achieving an outcome that we're all going to be happier with, that is going to make better utility of the human resources, as well as the funds and the gear to get us to, and probably dial down conflicting uses with all other sorts of stakeholders. So just highlighting the importance of that coordination effort. And I don't think we're very far along at that, but we need to move along that path rapidly.
Greg?
Yeah, thanks. That's a really good answer, Kira. I'd have to agree with you. I think from my perspective as, representing a developer and being responsible for getting our monitoring at our lease sites off the ground, I think we have to take into account the broader timelines of offshore wind in general and then project-specific timelines and the urgency with which developers often need to get a monitoring plan going. I think there's room for improvement when it comes to regional coordination. My job is I'm working across all of our projects, and so I'm trying to find those synergies and efficiencies wherever we can to collect similar data across our lease sites and also to have our data collection streams at least be as compatible as possible with other ongoing research collection efforts. And I think tools like acoustic telemetry help move us towards that more regional direction. That being said, I would agree that there's certainly a lot of room for improvement, and I think those conversations are starting to come to the forefront more, so I'm hopeful that we'll get there in the not too distant future, because I do, like everyone else, I think there's a lot of utility in not collecting duplicative data, not having duplicative sea time, reducing conflicts with other users, minimizing the footprint of monitoring, and saving money as well. So I think there's a lot of utility there, and hopefully we'll get there soon.
Yeah, and I'll take moderator privilege here and just say I think there's also some other communities that have struggled with this 10, 20 years ago. And I come from a world of ocean observing, and that was a conversation we were having 20 years ago, and it's turned into these really nice regional entities like the IU's entities and programs like MATOS for telemetry that are leveraging OTN and ATN and all of these things. So finding ways to, I think, get involved in those and get these programs involved in those as well. There's a whole pool of experts there ready to help. Next question. Did anyone else have a comment? Anyone else wants to answer how we're going to get regional? Okay. Kate? Yeah.
A good question for the next session.
Oh,
There you
right.
go.
Yeah.
Right.
Nice plug for the next session.
There's an online question that has several votes, so I'm going to get to it. Have gliders been successfully operated inside European wind farms in busy places like the North Sea? We don't want to build reliance on a sampling tool that will be limited after turbines are constructed.
Does anyone know the answer to that? So I can answer from my own experience. I'm not sure about specifically in wind farms, but gliders have been operated pretty extensively in Europe too. There's quite a few active groups that are doing it. We once partnered with a group in Liverpool Bay, and for those of you that have operated autonomous systems like this that are not tethered, Liverpool Bay is about the scariest place you could operate an autonomous system like that, because there is everything that could potentially attack your glider is in that bay, right? There's oil platforms, there's wind farms, there's ferry boats, there's tides that go at 6 knots, everything. And so I don't know the answer to that specific question, but I can say the community that has been operating these technologies have put them into some pretty tough places and have learned some best practices on how to operate them. I would say from the plans that I've seen, I would feel very comfortable moving a glider in through a wind farm that has a spacing that's been advertised in these projects.
Certainly better than trawling.
Any other thoughts or comments on that?
Just, it's certainly better than trawling,
Yeah.
right? Pulling a trawl in a wind farm versus putting a glider in a wind farm. It's all relative, right? Get another one. You lose it,
Yeah.
get another
Yeah,
one.
we could use Christian's mentality there. Right.
One more question online. Actually, we have several online, but I'll ask one more right now. Is there any autonomous tech or sampling techniques on the horizon that the offshore wind industry can support to advance to a high readiness level for use in actual research?
Let's go to me.
Greg?
Sure. Yeah, I mean, to some extent, we've already begun to do that, and I think that collaboration is going to continue in the future. At Orsted, we have a big focus on innovation and R&D, and we're trying to form partnerships with both, private sector businesses, but also with universities and consultancies across the world. So I think that's a big focus for our company globally, and I do think there is going to be a lot of great research that, comes out of this within the near future. So I think those opportunities are certainly there. I think we've seen some of that demonstrated already throughout the last 3 days, and I expect that certainly to continue moving forward.
Any other comments to that? I know just about every other week I get a new email from Christian of the next thing he's trying to put on his glider. So. But the one thing I will add with some of these autonomous systems, and I know Joe touched on this before, I think on Tuesday, and that's about the data volume. And a lot of these systems may not be able to send all that data volume. There might be some intelligence that you can put on these systems to do some initial analysis before that gets sent back. So I think not just in the tech, but developing some of that, whether it's AI on the gliders or some of those computing resources that don't take a lot of battery power, that don't need huge bandwidth. And also, we would welcome more bandwidth when that Iridium network goes up. That would be okay, too. Oh, here's a specific question to you, Christian, and we could also maybe broaden it for the whole panel. But as you went through this transition from vessel-based survey to autonomous system with the moorings and the gliders, what was your biggest surprise?
Probably that it was as doable as it was. You know, we were awestruck that we could get 90 days in the first deployment that we tried. The quality of the data was sufficient. You know, these were you know, Tony and Jen, that are our pilots, they were coming from zero. And we were able to do this and get it going. And so I think that, you know, every situation is different. And if they had to juggle a whole bunch of other stuff, would we have been so successful? No, we were mission focused on getting this way, but we were able to do it in 8 months. So I think in the end, you know, we have to figure out what they can do, and then, you know, put enough resources behind them to become proficient with them, whatever the tools are.
And there was a second part, and I'm going to try and broaden it so maybe the panel might want to touch on this. And that is, they're asking, what do you know now that you wish you had known when you started that switch? And I would broaden it to the panel by saying, what do you know now that you wish you had known when you started thinking about the different autonomous integration programs that you're putting in? Is there some piece of information that you'd like to tell 3 year ago you that would have helped you today? And maybe I'll start with Christian because it's most relevant maybe to your transition. Is there something 3 years ago that you would wish you had known now? And then give some time maybe for the panel to think just more generally in your context.
Nah, that's a hard question because it's just 3 years. We were pushing the technology pretty hard. So for example, the acoustic sensors that we were using, while they were good, you know, they couldn't handle doing 1,000-meter cycles 2,000 times in a deployment, right? We learned that one quickly, and so in every iteration, that was something that was up front in every contract that we sent out. Was you make sure that you're going to be able to do this at these depths in these cycles and evolutions, because you don't want to just be, you know, despite what I said before about just getting another instrument, they're expensive. And so you don't want to be replacing things because they didn't work or things. So thinking that through about what that actually looks like is important. And
Andy?
Yeah, I'm going to just reflect on something our ecosystem surveys branch has communicated to the center when we started utilizing optical systems for like our Atlantic scallop survey through HADCAM, which is a major change of massive amounts of data. And what I think they would say is, in terms of doing new things, everyone wants to be, not everyone, but there's a lot of interest in supporting the next bright, shiny object, and these advanced sampling technologies get people excited. And so you get that rush of interest or that first drop of money or slug of money. But thinking through what are these new data streams going to mean? What is the labor? How is the labor in your operation going to need to change in terms of annotation, in terms of data management, in terms of like when things break on them? Do we have the software engineers? Is that software proprietary from the entity you purchase from. So we just hired a HabCam engineer, Martina Martini. So those would be things that I know we've learned lessons on as we think to deploy it relative to the excitement of doing something new, but really thinking through, yes, we may be able to save a lot of money not using a ship, but there are other costs that maybe we haven't thought about, and thinking through that and making sure we're communicating to those that are supporting those efforts that after 5 years it still needs to work because the decision making still needs to happen.
I don't know. Being not an expert on the different survey methodologies, the biggest thing that has helped me in the past several years has been connecting with the network of people who are experts, who can answer the questions on how do we effectively build out a survey? How much does it cost? What are the data considerations that we need to have? And being able to communicate with both the experts and then with each other on kind of plans for the future, so that we're kind of being very efficient in the things that we're asking for.
Yeah, thank you, everyone who's been gracious for like all of the questions that we ask as we're developing these things, as Kate mentioned. And I would just say, one thing I wish I had known 3 years ago was how soul-crushing the state procurement process would be. But in all seriousness, it is really encouraging to see these kinds of conversations happening, because that's the only way that we can expedite all of this. So I just wish I knew that people were quite so gracious and nice, because it really does pay off to just directly ask and get the information that you need to move forward.
All right, so we have about 3 minutes left, and I want to do a lightning round for this final question, and not to put you on the spot. And also thank all of you and everyone online for those fantastic questions and participating in this panel in that way. The panel's only made positive by all of your inputs and that variety of questions, so thank you for that. So I'll ask this, and maybe we'll just run down the line. Advancing 5 years into the future, what is your vision for the integration of autonomous systems into the offshore wind sector? So now you're starting to talk to 5 years from now, you. What do you hope 5 years from now you sees?
Data's open, data's available, and data's usable by people, because it's gonna have a life of its own if it's available.
Yeah, I hope we see a lot of integration and some thoughtful, synergies created, not just between states, but also between the states and the feds and those regional authorities.
And I'm going to just second what Christian said, right? We can generate reams and reams of data, right? But if different scientists or stakeholders are not able to access or don't know how to access or use those data, then they're not nearly as useful as they could be otherwise. And so that, for me, I think is a challenge and an opportunity to really, again, this is back to regional coordination, work together to create data sets which are easy to use, easy to access, and therefore get used widely across all sectors.
We're going to need these autonomous solutions for NOAA to continue to implement our congressional mandates for fisheries and protected species management. So 5 years from now, I hope we have a fully designed and implemented federal survey mitigation program. So these questions, data, et cetera, are asked, the answers are provided, and we're able to move forward in an operational way.
Thanks. So I see, just over the next 5 years, obviously increased use of these platforms. I think the benefits are evident, and it's a more sustainable way ecologically to monitor for the impacts of offshore wind. So I think it's a necessary transition to make. And I think there's going to be a huge increase in the types and availabilities of these technologies, starting to leverage things like AI, like machine learning, and maybe some new sampling techniques like remote eDNA sampling. So I think that space is going to continue to evolve exponentially, and the opportunities there will be huge. I agree with all the other panelists, though. This works best when we have the infrastructure in place to facilitate this data sharing and really derive the most utility that we can from all of this fascinating information. So certainly a difficult problem. I think there's a lot of smart people who are interested in making it a reality, and I think in 5 years it will be. So I think the future is really bright in this space, and I'm optimistic.
Thanks, Greg. Kate?
I think two things. In 5 years, we're already starting to look at new areas for potential offshore wind energy that are further offshore, so bringing technology into newer environments. And then also we're switching from the pre-development phase into construction and operation, so utilizing technologies in later phases and being able to answer some questions about impact.
Awesome. Thank you so much. Please let me thank all of you again. We're going to answer the questions that we weren't able to answer. We'll ask the panel to help with that. Please thank our panel. And Christian, for your keynote, thank you. And enjoy the break.
Make sure I don't step right off the edge of the platform.